exam prep. So please join quickly and mark your presence. I hope I am audible and visible to all of you. Okay. So once again, welcome you all to BYJU'S exam prep, the most comprehensive preparation app for all the competitive exams. Okay. And let us start the session. So GATE Rankers 2024 Monsoon Series. Once again, welcome you all to this Monsoon Series for Computer Organization and Architecture. Hope I am audible and visible to all of you. Am I audible? Please confirm me once. If any one of you have not done it, this subscription, please do it immediately. And also please do share the class information with your friends. So please confirm me once, is my audio, video, everything is clear? Am I audible? Am I clearly audible? Just confirm me once. Okay. So before I begin the session, so let me introduce myself. Myself, Murali Krishna Bukkasamudram. I am having 21 plus years of teaching experience, and also I worked in different engineering colleges and also for GATE. And I am topper of NPTEL course in theory of computation and also certified as international engineering educator through IGP certification program. And I have mentored more than 50,000 students across the country in different core areas of computer science. Those are theory of computation, operating systems, computer organization, computer networks, digital logic, and ICT. So these are the areas of my expertise. So please join quickly, and you can just mention hi or hello. You can use the chat box for asking your doubts, and also please share this class information with your friends. Okay. I hope every one of you have attended all my previous sessions. Okay. In COA, I have started previously, and I started with one class in this Rankers Monsoon Series for 2024. Okay, fine. So shall I start the session? Some of you please say hi or hello. And am I audible and visible? Please confirm me once. Am I audible and visible? Am I audible? Is my audio is clear? Yes. Is my audio clear? Okay, fine. So now let us move on to the session. So actually there is a national level scholarship test for GATE exam. So this will be conducted on 30th July at 9 a.m. and to 9 p.m. You can register right now for it, and you can get up to 90% off on our programs. And you can take a decision and take a step towards success in the GATE exam by writing this national level scholarship test for getting more benefits in the fees. That is, you can get up to 90% off on our fee structure. Okay. So please try to make use of this. And one more workshop is there. There is a free and live interactive workshop. It's regarding master plan to conquer the GATE 2024 in just 6 months by Abhinav Negi sir. He is MTech from IIT Delhi and having 11 plus years of teaching experience. And this live class will be on 1st August at 7:30 p.m. Please try to make use of this. Okay. I hope every one of you will register for this workshop. 7:30 p.m. Okay, na? So shall I start the session? Okay, fine. Now coming to the first question. Consider a machine with a byte addressable main memory of 2 power 32 bytes divided into blocks of size 32 bytes. Assume that a direct mapped cache having 512 cache lines is used with this machine. The size of the tag field in bits is dash. So as you know, in the direct mapping, we are going to divide this total physical address into 3 parts. What are those 3 parts? The tag bits. Okay. Tag bits and also block offset and byte offset. Block offset is to identify one block out of the many blocks available. Byte offset is to identify a particular byte in the set of bytes available in the block. So either it is a byte or offset or it is a word offset. It depends on the word addressable memory or byte addressable memory. And the physical memory of 2 power 32 bytes. So each byte can be identified using 32 bits. So each byte can be identified using 32 bits. So these 32 bits are being divided into 3 parts. These 32 bits are being divided into 3 parts: tag bits, block offset, and byte offset. Okay, first of all, this block offset depends upon the number of catch lines. Actually, if there are 512 catch lines, it means each catch line we can hold one block. Okay, of size 32 bytes. So block size is 32 bytes here. So that if 512 catch lines are there, so that means if there are 512 blocks. So to identify one block out of 512 blocks, so we require 9 bits. 2 power 9 is nothing but 512. So block offset is 9 bits and byte offset depends on the block size. So there are 32 bits in each block. Okay, as you know. Hello, yes, hi Shyam. Good evening. Yeah, just let me know. Yeah, Shyam, let me check. I will explain to you. And 32 bytes, to identify one byte out of 32 bytes, we require 5 bits because log 32 is nothing but 5. So log 2 power 5 base 2 is nothing but 5 log 2 base 2. So it requires 5 bits. And 5 bits are used for identification of a byte within a block. So 9 plus 5 is 14. Am I right? And 32 minus 14 is how much? 18 bits. So remaining 18 bits are used for a tag, and these tag information is maintained in the catch controller to verify whether the address generated tag is matching with the tag that is stored in the catch. So for the tag matching is happened means it is a hit. If a tag matching is not happened in the controller, it is considered to be a miss. But the size of the tag field is 18 bits actually. And this tag information of 18 bits you have to maintain for every block. Okay, for example, we are having 512 blocks. Okay, 512 into 18 bits you have to maintain in the catch controller. For that, additional memory is required in the controller. That's what the criteria in the direct mapping. In a direct mapping, we call it as a direct mapping. There is no search time in the catch memory. So directly go to the controller and catch controller, and the main memory address tag portion 18 bits is compared with the respective address of the tag portion. If both are matching using the match logic, if you can implement, then directly we can go to that address using the index. So this block offset and byte offset together is index. Why 9 plus 5? It is because 9 plus 5 is a 14. So using 2 power 14. So that means catch size is this much, 2 power 14 bytes. How is the catch size 2 power 14 bytes? Because 512 lines are there. Every line means block 32. So it is nothing but 2 power 9 into 2 power 5. It is a 2 power 14. This is the size of the catch. Hope everybody understood. Shall I go for the next? I hope my voice and video, everything is clear. Yes, Swati. Good evening, Swati. I hope all of you are fine, doing well. And please attend the classes daily at 10:15 YouTube classes on this monsoon series. COA subject till Friday I will take. Today, tomorrow and day after tomorrow also classes are there. So please try to attend. And now coming to the next question, question number 2. Consider a machine with byte addressable main memory of 2 power 20 bytes and a block size of 16 bytes and a direct mapped catch having 2 power 12 catch lines. Let the address of two consecutive bytes in a main memory is represented in hexa, that is E201F base 16 and E2020 base 16. And what are the tag and catch line address in hexa for a main memory address of E201F? So E201F you can just write. So this is a hexadecimal address. Each hexa digit is a 4 bit. So E is nothing but 1110, 2 is nothing but 0010, and 0 is nothing but 0000, 1 is nothing but 0001, F is nothing but 1111. So this 16 bit of address we are going to divide into tag, block offset and byte offset as I have shown you. And it is very simple. There are 2 power 12 catch lines. So that means one catch line to identify. So block offset is supposed to be 12 bits. And the size of the block is 16 bytes. So that is nothing but 2 power 4 bytes. To identify one byte out of 2 power 4 bytes, we require 4 bits. So that means we can take this particular 4 bits as a byte offset, and these 12 bits block offset 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up to this is a block offset. So remaining will be actually what is the total size? 2 power 20 bytes now. So we are having total 20 bit address because 5 hexa digits, 5 into 4, 20. So these 20 bits we are dividing. That means these bits are used as a block offset or line offset, we can say. So that is of 12 bits, and these 4 bits is a byte offset within the line or within the block. These 4 bits, 12 plus 4, it is how much? 16, and 20 minus 16, these 4 bits. So tag bits are 4. So these 4 bits are used for a tag, and these 12 bits are used for a block offset, and these 4 bits are used for a byte offset as for the direct mapping. And what are the tag and catch line addresses in hexa notation? So tag is 1110 is nothing but E, and these 12 bits means 3 hexa digits, 3 4s are 12, so 201. So E comma 201 is the right answer. So option B is the right option. Yes, Shyam, you are right. Shall I go for the next question? Are you ready? And meanwhile, you can do subscribe the channel if you have not yet done the subscription, and you can share with your friends. Okay. And the third question is like this: a 16 kilobyte direct map write back cache is organized as multiple blocks, and each of size 64 bytes. That means it's a block size is given. Block size is equal to 64 bytes. Observe carefully. This is a different problem, but direct mapping only. Block size is equal to 64 bytes. So to identify 1 byte out of 64 bytes, we require 6 bits. Okay, and a 16 kilobyte direct mapped cache. So what is the size of the cache? 16 KB. 16 kilobytes of direct mapped cache. Write back cache. Okay, and the processor generates 32-bit address. So we are supposed to divide this 32-bit address into tag, block offset, and byte offset. Cache controller maintains the following information in addition to the tag. Actually, in a write back cache, in addition to tag, some additional information you have to maintain for every block. So 1 valid bit, 2 modified bits, total 3 bits. And the total size of memory needed at the cache controller in bits is dash. I have already told you in the previous problem, we have to maintain the tag information along with these additional bits for every block. Okay, first of all, how many bits are there in the tag? We will see. And what is the size of the processor address? 32 bits. So this 32-bit address we are supposed to divide now. This 32-bit address we are supposed to divide into how many parts? Tag bits, okay, and block offset and byte offset. So byte offset depends upon the number of bytes in a block. So 64 bytes to identify 1 byte, log 64 bits means 6 bits are used for the byte offset. How many blocks are there? Cache size divided by block size. So number of blocks is equal to cache size divided by block size. Number of blocks in the cache. Number of blocks in the cache is equal to cache size divided by block size. What is the cache size and what is the block size? You can note on this formula. Cache size divided by block size in bytes. Both you can take in bytes or both you can take in words. So cache size is given as 16 kilobytes and block size is given as 64 bytes. Okay, this is nothing but 2 power 14 divided by 2 power 6. It is nothing but 2 power 8. Am I right? So 2 power 8 blocks are there. To identify 1 block out of 2 power 8 blocks, we require 8 bits. We require 8 bits. Then 8 plus 6 how much? 14. So then 18 bits are tag bits. So in addition to these 18 bits, we have to maintain 1 valid bit, 2 modified bits. So for every block we have to maintain 18 bits of tag bits plus 1 valid bit, 2 modified bits. Total it is 21 bits you have to maintain. These 21 bits must be maintained for every block. Like that, how many blocks are there? 2 power 8 blocks are there. So 2 power 8 is nothing but 256. 256 into 21. 256 into 21 is nothing but 256, and 2 into 256 is 512, and it will be 5376 bits. 5376 bits. Is it there in the options? Yeah, option D is the right option. I hope you might have understood. Exactly. Samarth, you are correct. Shyam, you are correct. 2 power 18 to 21. So for every block, this metadata we have to maintain, data about data we can say. Shall I go for the next, or I have to wait? Please let me know if you are facing any difficulty in understanding, all of you. So this is all about direct mapping, and the problems will come in this model only for a direct mapping. Okay, like identification of number of bits for the tag, or identification of extra memory required for storing the metadata. Metadata includes tag information and additional information. So usually the write back catch, what about the block, we have to maintain some control bits to tell the status of that block, whether it is written or modified or something. And coming to the last question, consider a direct mapped catch with 16 one-word blocks, all initially empty. With respect to the given series of address reference, calculate the number of hits. Very simple. Actually, we are having 16 blocks. So 16 blocks we can number from 0 to 15. It is like this. Just I am writing here. And in the direct mapping, the placement of block in the cache depends on one formula. So this is the cache memory actually. In this cache memory, so these are the blocks, for example. It is a block 0, block 1, block 2, 3, 4, 5, 6, 7, and till 58, 9, 10, 11, 12, 13, 14, 15. So it is a block numbers I am writing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. 0 to 15, total 16 blocks. Okay. Now actually cache block number is equal to main, these are all main memory addresses actually. Main memory block number mod number of blocks in the cache. Cache block number. Cache block number is equal to main memory block number. Main memory block number mod number of blocks in the cache. Mod number of blocks in cache. Okay, so it is nothing but 1 mod 16. Number of blocks is 16, no? 0 to 15, total 16 blocks. So 1 mod 16 is 1 only. So here it is placed. And calculate number of hits. Hits means when the block is referred, it is available in the cache means it is hit. So 1 is initially cache is empty. So 1 is not available. We placed it from memory to cache, we placed it. And 4 mod 16 is a 4. So block number 4 we keep here. It is also miss because it is not available. We made it right now. 33 mod 16. 16 to 32. So 1 is the remainder. So 1 you have to replace, 33 you have to keep. Because 1 and 33 map to the same. And 5 mod 16 is a 5. It is also miss. 52 mod 16 is a 4. Because 48, 16 4s 48 and 4 is the remainder. So we keep 52 here. And 4 also again 52 replaced, 4 is inserted. That is also miss. 21 mod 4, 5. Because 16 ones and 5 is the remainder. So we have to keep 21 here. And 5. Again 21 is replaced. 5 is inserted here. 10 mod 6. So 10. We have to keep 10. 19 mod 16, 3. And 22 mod 16, 6. And 10 is available. It is a hit. 10 is the only hit. So single hit. Because we referred a block number 10 when it is already available in the cache. Why is byte 6? Yes, stay focused. Why is byte 6? You are talking about which question? Stay focused. You are talking about previous question. 6 bits is because the block size is given as 64. 64 can be written as 2 power 6. That's why. Okay, stay focused. I think now coming to this option B is the right option. Is there any doubt? You could ask me. So these are the two things you have to remember. This formula, cache block number to be placed is main memory block number mod number of blocks in the cache, and also the division of the address like tag, block, byte offset. Okay, these things you have to remember in the direct mapping, and there is no need of separate search time here because directly a part of main memory address is used to directly going to the cache controller and mapping with the tags. If tag is matched, it is hit. If tag is not matched, it is a miss. Like that we consider. Okay, so that's all for today. I hope you people have enjoyed the session, and please do share the class information with your friends. If you really liked the session, please do like it and share with your friends. Okay, and meanwhile, if you have any doubt, please ask me, and even after the class is finished, still if you get a doubt in the comment box, you can share your detail this doubt, whatever the doubt you get, and I will explain it. Okay now, and I hope every one of you have enjoyed the session, and tomorrow I will take set associate mapping and some more additional problems I will take for tomorrow. All of you please stay tuned for BYJU'S exam prep gate CSE channel, and please try to share the class information with your friends and do subscribe. Thank you so much. Thank you, Anandal. See you once again tomorrow at 10:15. Bye bye. Good night.